Welcome back to the next episode of Anthony and Ben Talk About
SQL Server
2025.
2025.
Yes. So I think we're gonna kind of mix things up. We have a new, I guess maybe not a new data type, but a new dimension. Oh, see what I did there to a data type that we've become very familiar with, and we're going to talk about
Yeah,
kind of the reasons why this came about, Ben, and we're going to look at some of the ways we would implement this new thing that you're going to share with the
yeah.
audience today. Let's go
Cool.
for it.
Let's dive right in. So, of course, I am running RC1 as one does. And the thing I want to show you today is a reduced precision in the vector data type, which is something that came in RC1. So I'm going to create a new database, which I'm going to call storage is expensive. I'm pretty sure you would agree, Anthony, right?
I don't know. No comments.
So, you know the drill. Master key, external REST endpoints. I'm using the same code I used in previous demos. So I'm going to create a table for conference sessions and grab some sessions from Sessionize again. So we got 30 rows
Mhm.
of data in here, which is from a data set today I helped organizing earlier this year, just so we have some data to work.
Wait, 30
Nothing
rows.
new.
That's gonna put a lot of pressure on those GPUs. This has
So
been.
that's the thing. I was considering spinning up big data clusters for it, but then I
Okay.
realized the containers are gone, so I did not.
Ah, which tells me you actually tried, and the containers are gone.
I actually still have the containers locally, just in case I ever feel like spinning one up.
Okay, just for old time's sake.
Just, just in case,
Okay.
if it's one of those days. Anyways, so I'm adding my embeddings column, which is of vector 768. So we got the vector data type, 768 dimensions. Again, nothing new here, and
Okay.
that will do exactly what it did in the previous episodes. That will do exactly what it did in the previous CTPs. And
Mhm.
what it does, it is using a precision of a float 32
Okay.
bytes.
What do you
Um,
mean by precision, Ben? You wanna dive into that now, or you wanna wait a little bit?
let's wait a little bit.
Okay.
But I'm going to write some code because it's not in here, but I'm going to write some live code to show you. Hang on. Let me get
Wait,
there.
you're gonna, like,
So,
write, like, a live demo?
like a live demo. We did
Okay.
totally not think this through. And I already have regrets now that I said it out loud, but at the same time, hey, why not?
Okay,
I'm
go ahead.
creating my external model pointing at my GPU powered machine. At this, honestly, this could be my CPU powered machine. It doesn't matter because
Yeah.
30 rows of data. And then I'm updating my conference sessions table here. The first one takes a little bit longer, 1.7 seconds. That's horribly long. Running
Mhm.
it again, 0.6. Exactly what we saw in the last episode where you were showing the parallelism across the multiple llamas. It needs to
Mhm.
load that model into memory. So the new thing I want to show you is besides just saying, hey, my vector has 768 dimensions, I can make it a float 16. So the default would be float 32. I can make it a
Mhm.
float 16. I just already started live typing in a demo. Um,
Careful.
and let me do this. Ooh, float 16 is not a recognized vector based type. And the reason for that
This is
is
what happens when you do live demos, Ben. Careful.
semi live. I was prepared for that part. It's going to get worse from here.
I
Um,
know. I
oh,
love when I
Lord.
break Ben.
It is what it is. So we've seen this before. Alter database scope configuration set preview features equals on, and now we can add this. So what this means is the vector data type has been around forever. I mean, by forever, I mean since
Like,
May, since we
at
did
least a
CDP
couple months. Yeah.
2.0. I mean, this is legacy technology. However, that subtype, if you want to call it that, or that sub precision, that float
Mhm.
16,
Mhm.
that just came in and it is still guarded, covered, whatever you want to call it, behind that preview feature flag. So you need to enable it to get that.
Got it.
Um, my entire syntax remains the same. So rather than setting my embedding 16, which I could also have just called embeddings 32, I will use the
Mm.
same AI generate embeddings code. I will use the same model and everything. So let me run this. And so this took slightly longer. If I run it again, it might be slightly faster. At this point, it has zero impact because the exact same string still gets sent to Olama through
Hmm.
Nginx. In my case, single threaded because I don't have that fancy schmancy setup of yours with the four Olamas that you showed it on the last
Oh,
episode.
oh, llama.
Olamai, or in my case, Olama. Or is it Olami? We don't know. We don't know. Um, However, the interesting part is if we use the data length function on these two columns, what you will
Hmm.
see is that the FP16, so the float16, is about half the size of my float32.
Okay.
Will this
So
make a
now,
huge impact or difference for 30 rows of data?
no.
Hopefully not. Not
No.
even on my cheapo all local SSD storage subsystem.
Okay.
But let's think back to that Stack Overflow database that we were talking about. The version of Stack Overflow that I used for my vector indexes, for example, where I'm only
Hmm.
using the post starters, that's about 25 million rows.
Yeah.
If for 25 million rows you can cut the embedding storage in half, that will make an impact.
Yeah. That's a pretty meaningful thing because, like, you think about the buffer pool, right? In addition to the actual storage
Yeah.
consumption, then we also have to think about, but does this impact the quality of the search then in any way?
So the answer is it depends, I guess. I mean, it has to in some way, because
Hmm.
obviously we're cutting away a couple of decimal points here.
Right.
For the data I tested with, including the
Hmm.
Stack Overflow data. But then again, it may vary with different prompts and all that. It had not make any impact at all.
Okay.
Still following that logic, when we did the vector searches or all these demos before, we were basically always sticking to the cosine algorithm. And then if you
Hmm.
check in the books and everything, so you use cosine for this and dot for this and Euclidean for that. And to me, it never made a difference. And I'm pretty sure
Right.
there is instances where it does.
Right.
So that's why I'm saying the answer is it depends. I would still highly recommend looking into this because if it can save half the amount of storage for more than 30 rows potentially, without giving up anything meaningful with regards to the quality of search results I'm getting, I think that's
Right.
a win. Okay, let me try something here
What is
by
happening
just
here?
removing. I'm not really live typing in demos. Yeah, you don't even see it here. Basically, you're losing on a bit of details on the past the decimal point,
Hmm.
but in the way this is visualized, I would now have to spin up that JSON a little bit and only get like really the first segment or something of it. Then, but you're getting the point. It needs less storage on disk, which is not something you want to hear, given that you work for a storage vendor. But let me remind you of the important thing that we mentioned in the very beginning. Storage is expensive.
I feel attacked.
Thoughts on this?
Again, I think this is a fantastic performance optimization. If there's no impact to the results that you're getting out of this, it just makes sense, right? Definitely kick the tires, as Ben said. Test to see if obviously in your system you still get the results that you want out of it. Because I think that's one of the interesting things about this technology is DBAs and architects and developers. We're so used to database systems that always provide a deterministic outcome, right? For this input, I
Yeah.
get that output. And now the lines are getting a little bit blurred, right? When we talk about things like similarity search, we're going to use different potential, algorithms to find things in a database, cosine, Euclidean, dot, and then also kind of massaging another data point, the length of the embedding that's generated for that, right? Again, if I can optimize the system and make it more efficient, more, and I don't know if performance is a word, more highly performing, and then obviously I'd want to explore this particular feature.
100%. And also maybe to add to that dot Euclidean or cosine or that entire thing. While I haven't seen differences there, I've seen huge differences when using even only slightly different prompts,
Hmm.
like being like, chatbots is my prompt, or my prompt is, I want to learn about chatbots in parts. Entirely different results, for example, when querying sessions against that, which means your prompt has way more of an impact than which algorithm you're using, which precision you're using, potentially even which model you're using up to a certain point. And
Yeah.
since the prompt is usually controlled by your users, it gets us back to the point you cannot control your users, so algorithm doesn't matter. Famous last words.
It's garbage in, garbage out still applies, huh?
That is still kind of
Yeah.
a thing. It's an evergreen.
Evergreen.
Speaking of evergreens, I got a jingle that's an evergreen, and I think we should play it.
Yes. Play the music, Ben.